Hi, good afternoon. Good evening. So I'll just introduce quickly myself. I'm the AI Business Development Manager for SKF Enlight AI. SKF Enlight AI is the new name of Presenso of all our machine learning and AI capabilities post-acquisition. This is a little bit about myself. Prior to joining SKF, I was on 5 years on the Dutch market, both as an entrepreneur in Nijmegen and a consultant in Amsterdam. I'll quickly dive into the thick of things. We speak about, market disruption. There is the term Industry 4.0. This term has been coined not too long ago, but what comes with it is today the talk about emerging technologies. We speak about AI, we speak about IoT, maybe sometimes RPA. But what is interesting is that these technologies are quickly getting traction and pace. And when we start adopting these technologies, we look that our customers are getting targeted on their new business models. What this means basically, when they have new business models, this means new ways to serve their customers and an impact on their financial strategy. When we speak about financial strategy, we also speak about total cost of ownership. This, of course, includes the usual suspect, the CapEx, the lifetime parts and maintenance costs, and of course, the downtime, as you already know. Today, our focus is going to be on downtime. Just to take a little bit of a step backwards, we look at a map, right? And on the horizontal, we have time, while on the vertical, we have the measured asset condition. As you already know, in the olden world, we had the reactive maintenance, where it was a break-fix model, and the asset failure was caught too late in the cycle. Then we moved to preventive maintenance, where it was a scheduled maintenance strategy, which also had its advantages, but also its limitations as compared to reactive maintenance. Again, to improve on the downtime, we move into the age of traditional predictive maintenance, a combination of hardware, micrologs, thermal imaging sensors, and also qualified engineers who could, at the source of failure, capture data and then, collect, analyze, and process for downtime optimization. And of course, the topic of our day today is going to be how we're able to infuse machine learning into this whole process. But of course, with ultimate aim of optimizing downtime for you and improving your financial strategy. So when we speak about various methods for predictive maintenance, when you look on the left, you can see, the traditional method, which was mostly hardware-based. This was, as we said, a combination of a hardware, a microlog, a thermal imaging sensor, and qualified engineers who could pick up this vibration data or this process data to then work on it. And then on the right, we're going to see now multiple software-based models. We start with an existing popular model in the market, which is called digital twin. The digital twin is basically a virtual replication of a real-time model. And then, we started 10 years ago with the data scientists, which have started replacing, the application programmers in internal IT teams. These guys are tasked to find solutions to specific problems using data science and machine learning techniques. And we introduced today the concept of automated machine learning. This is a generic concept. If you go and Google out there, it's a concept, a generic concept that we've perfected today in SKF. So these are the software-based models, whereas on the left, you find a hardware-based model. Now, all these models have their clear advantages and challenges. We start with acoustic and vibration sensors. As you know, as having a hardware and the qualified engineer to pick up information at the source, it is very good to do diagnosis. It is very interesting in terms of times of failure. But when we speak about scalability and cost, it really limits us. You have to really replicate this hardware. You really need to hire the engineers, and it's not really scalable. And when we speak about poor scalability, we speak about increased costs. Then we speak about digital twins and expert analysis, Of course, a digital twin is very accurate, but again, as you may be aware, with a digital twin, we cannot replicate across plants, across geographies, even for the same equipment. Then, of course, we speak about the manual data-driven modeling. As you may be aware, this is very good. It's finding a solution for a specific problem space, but then we come into the problem of demand and supply of data scientists on the market, because to find good data scientists with a specific industry knowledge is very scarce and very rare. So this is also advantage, but also in terms of a scalability and a cost, a disadvantage. And of course, automated machine learning has its own advantages and its limitation. And today, the great advantage and limited advantage of automated machine learning, it's our scalability in terms of deploying across a scale and getting into economies of scale with automated machine learning. And when we speak about economies of scale, we also speak about interesting advantages when it comes to cost. So this is really today a map of all the advantages and challenges in those different types of predictive maintenance approaches. So the question is, why choose when you can have it all? Today at SKF, we have all of these capabilities and offerings. On the acoustic and vibration sensors, we already have over the years now an offering called the IMX series. These are basically acoustic and vibration sensors, which can collectively collect data either in a wireless mode or a wired mode, and again, in terms of different varying types of bandwidth. This is available on the market. It relays information to a cloud service, and there we can collect, process, analyze, and visualize on real time for exactly what's happening at the machine level. Of course, the other offering that we have on the market, which is a new name for our remote diagnostic centers, is called the rotating equipment performance centers. These are basically experts sitting behind computer screens who are actually able to capture the information coming from the sensors, analyze them, find the root cause analysis, and provide you with expert recommendation. This is an existing offering on the market from SKF. Of course, we also provide manual data-driven model services, and these are basically, AI ML experts inside SKF who are currently working with customers across the globe and defining solutions with AI and ML infused with domain knowledge from SKF. And of course, today with the presence acquisition, SKF today has in its portfolio what we also today rebranded as Enlight AI machine learning capabilities. What is interesting for you to know is that today we are actively working with multiple customers around the globe to infuse all this industry knowledge into our machine learning capabilities. This is domain knowledge across wind, across oil and gas, across pulp and paper, across all the various industries that you represent in our call today. We are actively working with customers, infusing this knowledge, and with the acquisition of Presenso, we've also acquired today with SKF machine learning capabilities. Now, of course, the interesting question is, how does it all come together? On the left, you see the vibration data, and you see the sensors from SKF. This is, as I said, the IMX line of offering, where we're able to collect vibration data at the source, at the equipment source. And then here you see process data. This is at the machine level, and this could be temperature data, vibration data, or pressure data. Together, we collect these type of data and send it to our Enlight AI machine learning brain. This can be deployed in multiple modes, as we can touch down the line. But what is more interestingly, we apply our machine learning models to create smart alerts that can be either fed to our rotating equipment performance centers, which are basically our managed services offering, or directly to you, to your customer O&M team. Of course, what happens there, well, basically either the rotating equipment performance center or the customer O&M team does a root cause analysis based on these alerts, and then trying to find the corrective action recommendation. Of course, today also SKF already has offerings in this line. So if it's a lubrication problem, you have Recon Oil. If it's application reengineering as a solution that you need, we also have this as an offering today. If the need is to remanufacture the bearings, we also do that. And if it's a supply chain optimization solution, we also provide that in the market. Of course, this is also fed back into the corrective action recommendation, and this closes the loop. What is two things I want to highlight on this slide is that today we are a unique provider of this end-to-end solution. So right from data gathering to problem understanding to solution to analysis to solution, we can provide this end-to-end in the market today. Of course, there are a lot of players who are specialized here, a lot of players who are specialized in machine learning capabilities, some players doing pure managed services for your industry, but very few can do it end-to-end. That's one thing that I want to highlight. The other thing I want to highlight is that all of this is modulable. You could today only purchase or get offering of Enlight AI. You could have a need only for variation data. You could choose, as we show here, the RDC or not, and all of this is modulable. So feel free to pick and choose. This is a buffet menu. Now, of course, our conversation today is around our Enlight AI, which is our automated machine learning solution. Automated machine learning is basically two pieces of it. First part is unsupervised machine learning. Not to get too technical, but just to tell you that with unsupervised machine learning today, we are able to cut down a lot of manual effort, which was previously not possible with semi-supervised or supervised machine learning models. Just basically, we're able to achieve a lot of data pre-processing on your type of data, on your process data, with a level of automation which is amazingly accurate and fast at the same time. The second part of automated machine learning is that the whole concept of automated machine learning is an evolution of machine learning in itself. We've been able to encapsulate all these advantages of automated machine learning, which means that we've cut down a lot of the human involvement in terms of the data scientist work, and we've automated that itself. So the involvement of the data scientists into this process is as minimal as possible in the whole line. Now, why, of course, we've chose AutoML, right? First value proposition and the benefit of automation of our AutoML is that it's a single solution for multiple machine types. Whether it's a mill, whether it's a compressor, whatever be your machine type that you have today, our super algorithm can smartly recognize the machine type and deploy the right fit algorithm for your need. So as you can understand, in the older world, for each of these machine types, a specific solution had to be customized to find the right solution. With our technology today, our super algorithm can quickly deploy the right fit algorithm for the right specific machine. The second value proposition of what we propose today with our technology is a cloud-first, quick-to-deploy solution. We have a very low customization timeline, and when we speak about traditional IT deployments, which used to take a year and a half, with cumbersome teams, developing, testing, and deploying these solutions, with our technology today, we have quicker time to market, which also means for you quicker ROI and better customer satisfaction for yourself. So this, our plug-and-play solution, can really give you the confidence and also justifies your investment, your management, in terms of why you should go in this direction, right? And then very importantly, we speak about self-adapting and self-maintaining models. And that's a very key, unique proposition of our technology today, and I'm going to touch upon that in the next slide. Now, what I mean about self-adapting and self-maintaining is very important. On the left-hand side, we see a machine, right? And at the machine level, we collect, as I said, multiple types of process data, temperature data, pressure data, and all type of process data. So let's call this the problem space. On the right-hand side, we have the toolbox, the SKF Enlight AI toolbox. Just like a toolbox which has a lot of tools, in our case, instead of physical tools, we have algorithms. These are machine learning algorithms. And when we speak about machine learning algorithms, these can be either proprietary or open source. These can be statistical models or purely, machine learning models. What is important for you to know, we then do a smart matching of these algorithms in a best fit manner to the problem space, right? Nothing new. But here's what we do with our technology. We use machine learning techniques, and in machine learning, there's a term maybe which is called the F1 score. Again, it's just a performance score and ranges from 0 to 1, where 1 is the highest and 0 being the lowest. Of course, when we first initially train the model, we try to achieve a highest possible F1 score. Of course, that also depends on the quality of data that we've been fed. But what we do smartly, and that's really the uniqueness of the intellectual property of SKF Enlight AI, is we continuously check that this F1 score is the best optimal outcome that you can get. So basically, if there's a degradation in our algorithm due to changes in the machines, and of course, with temperature rise, temperature drop, pressure rise, pressure drop, degradation in wear and tear, we either recalibrate the model or entirely replace the algorithm with another best fit to keep on our performance scores. And what's very important is all that happens automatically and seamlessly in the background. And that's really the uniqueness of our IP today, is really around this unique matching, continuous checking, and performance guarantee of our technology. And we can do that really seamlessly in the background. So you always get the guaranteed level of performance to make sure that you get the required business outcomes. Now, of course, what is very important for us to stress today, with the acquisition of Presenso, SKF being a world leader in bearings, a world leader in rotating equipment performance, we are able today to do this prediction at machine level and not only at the rotating equipment or at the bearing level. And moreover, we do this prediction at, as we said, the sensor level, vibration sensor, pressure sensor, temperature sensor, but we add an extra layer of correlation on top of that. And that's what really gives us the advantage to do machine level prediction. So today, SKF is able to give you a machine level prediction with SKF Enlight AI technology. Of course, our competencies revolve around bearing failure, bearing management, rotating equipment performance, but this is today another level of performance we can guarantee with SKF Enlight AI. We start with anomaly detection, but then with good quality data, we can move to machine failure prediction. The machine learning brain of Enlight AI is basically today split into two. The first part, of course, as we already spoke, is, and that's our key solution today, we predict machine failure. So everything that we do is to reduce your downtime by predicting machine failure. And of course, internally and technologically, there are multiple steps to reach there, but that's our key benefit, our technology. What is currently being built, and that's going to be part of our roadmap and the next versions of AI, is the root cause analysis. Today, of course, as you can be already questioning, is that after we've done machine failure prediction, what happens next? Of course, we feed this to the operations engineer, operation maintenance engineer. He does a root cause analysis and then goes and finds a solution. Today, we're actively training our machine learning knowledge base to also learn from this root cause analysis and the corrective action actually happening from your engineers, from your field sales people, the field services people. These field services people will feed back the machine learning brain with a corrective action. And 1 year, 1.5 years, or 2 years down the line, our technology will not only be able to predict machine failure, but will also smartly suggest to you the top 5 root cause analysis and even the corrective recommendation. So we're already very strong on this part today, and we're actively building this next phase. And we already have very good feedback from customers, from early pilot customers for the root cause analysis. Now, before getting into the demo, I just wanted to show you some level of what you will see. We have some dashboards to show you with the demo today. Of course, we start with a global view. The global view represents if you're a global company with plants across the globe, you're going to see on a one-shot view where you should focus your attention and which plants are currently to be monitored. This is done by our machine learning brain, and of course for critical assets which are relaying data back to our SKF AI cloud. The second view, of course, is a drill down from the global view to the side view. The side view, of course, as you can imagine, which the word says, is basically specifically what's. Sorry, was there a question? Okay, it's my own echo. My apologies. So the side view is basically a one-shot view of all the critical assets which are being monitored in a specific site. So basically, if you have 3 assets or 3 equipped critical assets being monitored here, you're going to see all that in your map. And of course, as I'm going to show in the demo, you're going to see the events which are being logged for these different assets. And then, of course, you would want to drill down in a specific asset and look at, a possible failure prediction. Of course, here you're going to see a health line, and along the health line, you're going to see the different tags which have contributed for a prediction of failure, which have been, in some cases, predicted 10 to 15 days before the failure happened. But from global view to side view, from side view to asset to machine view, and then, of course, you want to specifically zoom in a specific tag, and that's called the sensor view. I'm going to show all that clearly in the next demo, but just to give you an overview, these are the dashboards are available today for SKF Enlight AI. Now, just as a showcase, prior to the acquisition, Presenso was selected by Siemens Energy. This is a big oil and gas major, and there's a big deployment today going on with Siemens across multiple locations in Europe. The contract scope today is all about remote diagnostics, operations and maintenance services, and also Enlight AI, in, as we said, minimizing downtime on their critical assets. Now I'm going to go into a demo, so please allow me to switch to a web page. Can you confirm that you can see my screen? And it's a web page that you need to see.
No, not yet. Not
Okay.
yet, City.
Does this work now?
Now we see a desktop.
Okay, can you say web page?
No, we don't see a web page.
This should be better.
This one is okay.
Okay, great. Thank you very much. So as I said, this is a site view. And in this site, there are multiple machines. Okay. And on a helicopter view, we have a health indicator, which is the stability indicator. And by the color coding, blue being a healthy asset or machine, yellow being less healthy until it becomes red. So in this site, we have a V400, we have an energy monitor, we have a gas compressor, and all these are being monitored in SKF Enlight AI. And you can see this being represented here in this chart. And among all these assets today, we have a total of 75 events which we were able to capture. Of course, what you want to zoom in here is a specific machine which is of interest. Let's now focus on one of these machines. I'll take, for example, the V400. Click on it. Right, so now we are specifically looking at a specific machine. The web page is still loading. Right, now this is a stability indicator for that specific machine. These are alerts. These blue dots, these blue circles are alerts which are basically sent by email to an operations engineer before a failure happens. This is your sensor heat map, and this is your tag cloud. I'm going to show that in a specific example. Let me choose a specific timeline. Let's say February 21st, 2018 to 20th Feb 2018. And I zoom in on that. Okay, great. Now, on the 28th of Feb, on the right-hand side here, this is a failure event in that machine. And 6 days before, an alert was already sent. And this is the alert. The bubble here is the alert which was sent to whoever has been configured in the system. And what is important to say is that this is a prediction of a failure which has been done 6 days before the actual failure event. Of course, what is of interest to you is what exactly happened before the event. So we're going to zoom into that just before an alert was sent. So we zoom. After we've zoomed now, we get the corresponding tag cloud for all the tags which are on this specific asset. And what you can see here is a heat map and all the tags which are on these machines. And by the way, there are a total of 274 tags. But let's just focus back here. I can toggle on and off all the interesting tags and most probably the major and significant events just before the alert was sent. So you can see on the 21st, on the 22nd, there were major and significant events which contributed to the prediction to happen. Of course, you can also see here in the tag cloud, which are these top tags that you can focus on. As you can see, this is a top tag which contributed to this specific failure event. Let's try to find one of these. So LIT 410051 is just one tag. And you can see this is one of the main tags, which was basically the culprit leading to the prediction of a failure event. Of course, what I want to do is to zoom in on a specific tag. So I click on one of them. And I can see now in that same timeline that I zoomed in, what exactly happened on that specific tag. And this is the tag mentioned here. And then you can, of course, look at real patterns of what caused that prediction to happen. So of course we can switch on and off. I'm going to keep only the major and significant events. These are the ones here. And you can clearly see on the 21st and 22nd, there were multiple repeated major events and one significant which caused it. But of course, as we said, we don't work on only one tag. Our machine learning prediction algorithm works on a correlation feature. So what you can do here, you can keep on adding tags. And you can see these tags are basically being populated in your visualization view. And you can see for the same timeline, what you can deep dive into for a lot of correlated tags. And this is called the correlation view. What is very smart from our software, for that specific failure event which was predicted, we also use machine learning to give you the top 5 suggestions so that you can really zoom in on the top 5 tags which cause the prediction, the machine learning failure prediction. Of course, as you know, we are monitoring more than 200 tags. So of course, if you have to go through all of these tags one by one, it's going to be a never-ending situation. So today, we can smartly use machine learning to quickly give you the top 5 tags which are of interest to you so that you can quickly get to your analysis, to your root cause analysis, and further down the line, your corrective action. But as we said, this takes you from the demo perspective, from the side view to the machine view, right? And to the tag view, and even in the tag view, the correlated tag view. And as I explained today, we are actively improving our knowledge base on these root cause analysis and even the corrective maintenance actions. If you can see here, this is a comment made from a field service engineer who went back to a system and tagged that event and said, we found an issue with the pressure, the seal is broken, and we're actively doing that. As you can imagine, when we start feeding multiple type of such comments and root cause analysis and corrective action into the knowledge base, our machine learning algorithm will get at some point so smart, it will also suggest these kind of corrective actions and well, first root cause analysis and corrective actions. So as I said, this is going to be part of the next versions of the software. This completes my demo of the software. Please allow me to get back to the presentations, and then when we can get to some Q&As. Can you see my presentation?
I think so. It says demo and a bearing to the right.
Yeah, thank you very much. So now this is a little bit of how we approach and work with customers today. We have a very methodical way. We do an assessment workshop, and what is of interest, we ask you to give us, your top headaches, which are basically your use cases. We do both a business value assessment. For example, when we speak about downtime, we really zoom into, how much, for example, how much downtime costs you. For example, some customers come back and tell us, per hour downtime costs us 30,000 euros, right? And that's really a starting point to, start building a business case. We also do a technical feasibility analysis. We really want to make sure that today we have enough good quality data. We have, a cutoff for our timeline of how much data, how good quality data we want to. For example, 6 months to 1 year of historical data. Of course, this is machine learning, and we need to learn from failure. So we need some failure events in your data. We have a minimum of that. So we do a very methodical way of looking at how, we can really select among these use cases the best pilot use cases for us to work together. This clearly is tied to our CSF, our success criteria, and really becomes the scope of our assessment. Now, what is important is that mapreduce for it. We work in two models. One is the offline project model. As the word says, we really do this in a very low risk threshold for you, which means we ask you to give us anonymized data in a CSV format, which we upload to our AWS cloud, and in a 4 weeks sprint project, and as minimal SME effort from your side, we can deliver the results in an agile way for you. What is very important for you to understand is we really work in a proof of concept model. As I said, for example, if I ask you for 1 year of worth of data, you give us only 9 months of that data, and we're going to be able to predict to you what happened in the next 3 months. And we'll call that the blind date. And when we feed you about the predictions, you will take that and cross-check that with your data. Because anyway, you have 1 year data, you fed us the first 9 months, and we predicted the last 3 months. But then you have the real actual way of how it happened. And then you cross-check that with our results, and only when you're satisfied, we call this, a successful project after milestone 1. And after only you believe that our technology really delivers the value for you, that we get into something which is called an online project, which is a bigger project, where we start speaking about, a bigger scope, production kind of projects, and, we really get into a commercial discussion and how we can create value for you on a larger scale. But really, we work on a low risk fashion, start with the online pilot project, start small, prove the results, and then grow big. And then we are doing that with a lot of customers today. We really see this as a success point for us, and it really, point of proof of concept for us today with our customers. I will leave this slide now to Ringo, to my colleague Ringo. He's going to give you a little bit of an overview of the next exciting webinars and events being conducted by SKF. Ringo?
Yes, Sati, thank you very much so far. Before we go into a little bit more detail about the information in the next webinars, I think there is some time for some Q&A. I have found some questions in the chat box, and I would really like you to answer those. The first question is, how is AI algorithms dealing with false positives?
Sure. So today we use our unsupervised learning model, and we're able to learn what are false positives and false negatives. The way we do that is in the first phase, when we train the machine learning model, we teach them how to work on that. So basically, when we do the first level of training, we teach them how to work with false positives and false negatives, so that when we give them the test data, they're able to understand how this is. So this is clearly an input from your side as an SME into what works for you and for your specific use case.
Okay, thank you. We have another question. Is the dashboard in Python?
The dashboard is in Kibana, which is AngularJS. These are usually technologies which is out of the box. The algorithms, actually, the algorithms behind the dashboard are in Python, yes.
Okay, thank you. Another question, is it possible to make long-term predictions of expected failure for months or even years into the future?
This really depends on the data set that you're being provided to us. As we said, we do prediction based on what we learn from your historical data. Today, one of our leading customers, where in normal times they do, let's say, traditional maintenance in terms of a couple of days, we're able to do that in terms of 15 days to 16 days in advance. So an advantage of 10 to 12 days better than the 2 days gap. We've not come across a situation where we can do that a month or two before, but it really depends on the type of data and your specific use case. So it really depends on your use case and the type of data that we are fed. But right now we're able to do it in terms of days. Well, of course, when we speak about 14 days, that's a couple of weeks before. But right now, no such use case where we do that in months.
Okay. There's also a question how you use unsupervised machine learning.
Yes, that's a very good question. So as I said, there is these first stages in the data pre-processing mode. So what we do with unsupervised machine learning is really, to skip the labeling of data, to prep the data for actually the supervised part of the machine learning piece. So today we use unsupervised machine learning to quickly label process data, pressure data, temperature data, what is good data, what is bad data. And instead of using human interaction, our unsupervised machine learning model is able to do this labeling without human intervention. And that's what we use unsupervised machine learning for.
Okay. Another one is, what is the supervised machine learning methods predict? Is that
Yes.
RUL?
Yes. So the supervised machine learning model predicts failure. And that was the part of my presentation. So when we've done all this data pre-processing, the second step we do anomaly detection. And when we've done anomaly detection, we've fed the system, as I said, and that's part of a key part of our data requirement, is that we had to have a minimum of failure events in our data. With the supervised piece of the machine learning model, we are able to predict failure based on learning from past failures in the data.
Okay. You also talked about different monitoring models, but if I understood correctly, you will always need in the beginning to install all sensors and the communication infrastructure at the machine. So in this case, it is also limited scalable without limited investment.
Good point. Not exactly. We work in multiple models. Some customers who doesn't have right now sensors sending information to cloud databases, we work with the SCADA system and historian systems, which are already in place. We're able to connect our pipes in a web services model to these systems, or you can even get us a dump of that data, but we can work in multiple ways, whether you have sensors or not. Of course, today with the offering of, as we said, SKF sensors on the market. We have better quality data coming from these sensors, but we can work in multiple ways as long as we have good quality data coming to us. So whether it's sensors being there, giving us data, SCADA and historian systems who are able to get this data for us in a prep way, or even a CSV dump to us, we work in multiple ways. It's just about getting good quality data to our system. So multiple ways of working in multiple modes.
Okay. I also saw a picture of a neural network. What other types of models are used?
Today, we're using a lot of statistical and regression techniques, but primarily we're using Bayesian theorems within the machine learning world for prediction.
Okay, and the last question so far is, don't you think we are losing the knowledge base with neural networks because they don't explain their decisions?
That's what I said. Our model today is really, working with your SMEs to imbibe those let's say domain expertise and those real decisions into the machine learning brain. As any technology, and not only AI, the technology only stands there to enable us to execute a specific business role. Today, that's the whole point of working with you closely to infuse all these business rules into the machine learning model. Of course, neural networks versus Bayesian theorems, we have a finer detail of which, and that's a technical discussion where we can really see which one is best and all, and which one is more appropriate to a specific use case. But whatever it be, the type of machine learning technique that we're using for your use case, we really need you to help us with your subject matter expertise, the algorithm contextual information, so that we can make sense of it. Without contextual knowledge, without your support as an SME to give us the business knowledge, this is not going to give you the real value. So it's this hand-to-hand work. Without business knowledge, the machine learning doesn't work. Without machine learning, we cannot do smart prediction failure. This is a hand-in-hand work to do contextual information and real business value for you.
Okay, Siti, thank you very much. Okay, this was the last question. I think we're just a little bit over time, but I would like to take the opportunity to let you know that we have some more interesting webinars on the planning. This was, as said, the last one in the series of 4 with NVDO. If you have missed one or you want to listen back to it for recording, don't hesitate to contact me and ask me for providing you with this recording or handout. When we send out a handout of this presentation later today, I will provide you with the appropriate email addresses so you can send it where you whenever you like. Okay, this is an overview of the upcoming webinars. Take a look at it. Maybe you can take a look at our website. You will be able to link to that site later when you receive the handouts. Okay, Siti, again, thank you very much. Thank you to everyone who has joined us this afternoon. It was a big number of people. We really appreciate that you spent your precious time with us. Until next time, we wish you a happy day. Stay safe, and hopefully we'll meet you next time. Thank you very much.
Thank you. Have a great day. Bye-bye.